So implicit differentiation now with chain rule. And so you can see that we're going to be using chain here because we don't want to expand this. So that is now our inside. So we take the derivative of it. It's 2x minus 2y times, and then now we're going to take the derivative of the inside. So I still like to write inside off to the side, and that becomes x minus 2y. And so now we can do inside prime. And again, we're doing this with respect to x. That is our variable. We'll just change it to that. There we go. So derivative of x is 1 minus, and then it's 2. And then now we put times dy dx. And again, I like y prime. So 1 minus 2 y prime. So there we have it. That's our inside. And then we multiply that over here. Make sure you always put it in parentheses. Just like that. And so now we can continue on. So that was implicit with chain. So you just do normal derivative to x minus 2y times the derivative of the inside, and then multiply it. So now derivative of x would be 1 plus derivative of y would be 1. But again, it's not an x, so y prime. Remember, that's our dy dx. All right, so now we just need to make sure we put everything on the same side. And so what we need to do is now some distributing. So this is 2 x minus 2y times the 1 minus 2 times x minus 2y times the y prime there. So I just put the y prime at the end. So what I'm doing is this times the first one, and then this times the second one. So the whole idea is to get that y prime out. And the reason I'm distributing it this way is I don't want to do a full binomial expansion. So if we had this as a degree 4, that would be a 3 and a 3, and it would still be massive. So I'm just distributing it. Can you binomial expand it? Yeah, it's completely fine. In fact, I'll do it at the end after we finish this part. Plus 1 plus, oops, it's an equals, plus y prime. Put it in red. All right, and so now we can sort. So this is our y prime stuff. And so it needs to be on the same side. So we end up with y prime. I'm going to put that one first because it's positive. Minus 2 x minus 2y y prime equals 1. And then we subtract that to x minus 2y. You know what? I'm going to multiply it out and then do the distributing of it. Yeah, let's just do it that way. Okay, so this is one method. I'm going to show you now 2 ways to simplify it. You get locked in sometimes. This is implicit differentiation with chain rule. If you're using the notes, I've changed that to a 4 to make it a little more interesting. So how it works is we do normal derivatives, but we're just taking it with respect to x. So we bring the 4 down, and then we do x minus 2y, and then 3 times, and now we have to multiply the derivative of the inside. That's our chain rule. So we have our inside over here. I like to always write it off to the side and then take its derivative. And so derivative of that with respect to x would be 1 minus 2, and again we have to write dy dx. So we end up with 1 minus 2 y prime. So we don't actually apply the dy dx until we hit that implicit differentiation part, which is right here. So you have to think this is a function that we just did. So we brought down the 4 and we changed that to a 3, but this is our function like g. And so now we're doing g over here. All right. And then this is our dg dx, but within our dg dx we have a y, so we have to also do dy dx. So we're applying chain rule twice here. So now we can put that one on there. But again, you don't have to think that far behind it. Just don't apply the y prime until you actually hit the y prime. So this one was not it. Just bring down the 4, change that to a 3, and then there you have it. Equals, and then now derivative of x is 1 plus, and then derivative of y is 1 y prime, because it's not an x Okay, so now we don't want to just expand this. You can, and you can multiply that, but that's the whole point of doing this with chain rule. So what we do is we just distribute it. So we're going to take this quantity here and distribute it to the two parts, and that will allow us to bring the y prime out. So we end up with 4x minus 2y cubed. Now be very careful, that is a cube. You cannot distribute that 4 inside, times 1, so it would just be that. And then we get 4x minus 2y cubed times 2y prime equals 1 plus, and then I like putting the 1 in front so it just reminds me there's something there, y prime. So now you can see that this is part of our y prime, and this is part of our y prime. So those two need to be on the same side. So we end up with y prime with the 1 minus 4x minus 2y cubed y prime. And so that 2, let's combine it with that 4 to make it an 8. And then we end up with 1 minus 4x minus 2y cubed. So there we have it. So we move that one over, and now it's a minus. We move that one over, and now it's a minus. See, always double check these. So that's a minus, minus, positive, minus. Everything is good. So now we factor out the y prime. But again, you already should see it. Y prime equals, and then that's our numerator. So 1 minus 4x minus 2y cubed over, and then the other one's our denominator. So negative 1 minus 8x minus 2y cubed. And you can keep simplifying if you want, or we're going to stop there. And I'm going to go back and factor that y prime out just so you have it. So that would be negative 1 minus 8x minus 2y cubed equals 1 minus 4x minus 2y cubed. And then again, numerator, denominator. All right, let's try one with a trig function. So we're now going after that sine. So we're trying to get to the inside. And if you notice, the inside is actually a product as well. So this is chain because there are parentheses around that x and y. So derivative of sine would be cosine xy, but then again you have to take that inside and take the derivative. So I'm going to write it over here with an I, and that's xy. So that was my inside. Okay, so now taking the derivative, we go back to our product rule. And how can you tell it's product rule? Because it's a multiplication between the two variables. And so we have a y. We'll put the y in green so we can sort them. All right, derivative of x is 1. Derivative of y is 1. But again, it has to have a y prime, a dy dx. And then we do our multiply. So that would become y plus x y prime, and then now we can multiply that on here. And you should be seeing patterns here. Now the other side is also a product rule. So this is y times sine x. So again, that would become y and sine x. So derivative of y would be 1, and again, y prime. And derivative of sine x is cosine x. And then we do our little multiply. So that would become sine x times y prime plus, and then y cosine x. And that is what we get on the other side. So sine x times y prime plus y cosine x. Okay, now let's finish this. So again, we need to put our y primes on the same side, but we can't with our cosine x sitting there. So you can divide both sides by cosine xy if you want. That would be completely fine, but I'm going to distribute just to keep our pattern the same. So y cosine xy plus x cosine xy times y prime equals sine x y prime plus y cosine x. Okay, now we put all our y primes on the same side. So these guys right here, this one and this one, need to be on the same side. So it would be x cosine of xy, y prime, minus sine x, y prime, equals y cosine x minus y cosine xy. And then you cannot add these are not like terms. That's an x. That's an xy. All right, so then again, y prime equals, and this is our numerator, and this is our denominator. So y cosine x minus y cosine xy. And the more you do these, the quicker you will get at them. X cosine xy minus sine x. Now be okay with making mistakes. These are not simple. So if you make a sign error here or there, some sort of algebraic error, they're just things you have to work on checking. But the one thing you always want to make sure you check are the signs when you transfer them. So that one was positive, that one came over, so it's minus. That one went over, so it's also minus. And then also transfer error. This is where most of the mistakes occur, is where that transfer error is. Everything looks good, like that's a y and now it's still a y. We're good.